I am Liz. I work for Aqua Security. Aqua has a solution to help enterprises deal with securing their containerized deployments, and that covers lots of things: vulnerability scanning and runtime protection, and some secrets management capabilities. But you don't need to be using a tool like Aqua to be doing sensible and useful things with your secrets. There are lots of things that are built into orchestrators, and I want to review some of those things, maybe do some demos. I'm having VM nightmares, but we'll cope with that when we get there. And look at some of the things that you might need to just pay attention to when you're managing secrets. So first of all, what do I mean by a secret? So obviously it's something that you don't want other people to know. It's kind of obvious. I'm talking about the kind of secrets that your code needs in order to operate. So maybe your microservices might need tokens so they can hit APIs, or they might need passwords to access databases. I'm not talking about the secret information that's inside those databases. You know, you could have all sorts of really sensitive stuff inside there that is protected by things like your database passwords. I'm really talking here about storing and passing around the information that your code needs in order to do its job. So let's have a little consideration about sort of the characteristics we would like to see from our secrets management solution. The first thing is, we would like to keep our secrets encrypted, whether they're in storage or while they're moving around between nodes. We'd like to see them being encrypted. We only really ever want to see them in plain text if they're in memory where they need to be used. Why do we want to keep them encrypted? Well, it is always going to be possible that somehow somebody, a bad actor, gets access to your machines. And if they do that, if there are secrets lying around in plain text, you know, you've given them the keys to the castle. We would ideally like to limit access to secrets on a kind of need-to-know basis. You might have an architecture that's broken into all these different microservices, and they're all running in these different containers. And if you only give access to secrets to the containers who need those secrets, then if a given container gets compromised, the secrets it's got access to are compromised too, but you haven't potentially lost all of your secrets. So being able to sort of limit access to individual containers is a good thing. You might also need access control for the users who are running in your system. You know, particularly if you're a large organization with lots of different projects running, not everybody needs access to the production keys for everything running across all projects. Another thing to look out for is write-only access, which is the idea that you can set up a key. You know, as an administrator, you can enter the value for some password, but you can't necessarily retrieve that easily. So it goes into a location. You can change it, but you can't read it back. The longer a secret is in existence, the more likely it is that something bad will happen and somehow it will get leaked, whether it's, you know, by somebody doing a bad thing or just stupidity. Somehow secrets can get leaked. So you know, maybe you know about the fact that a secret has been lost, in which case you want to revoke it, like changing your password. You don't necessarily know when a secret has been lost, when an exploit has happened. So you might want to rotate your keys, by which we simply mean change your passwords, change your tokens on some kind of scheduled basis. And depending on the kind of organization you are, you might have requirements around compliance. You might need to log when secrets get accessed and who's got access and when they've been changed. Having that audit log could also be really helpful if you've got to do some kind of forensic examination after something bad happens. How do you get secrets into the code running inside your containers? Well, there's some bad ways. A bad thing would be to bake those secrets into source code somehow. Why is this a bad thing? Well, it's bad because if you want to change the value of a secret, you've got to do a code deploy. It also means your secrets are visible to everybody who's got access to the code, and not everybody necessarily needs to have access to all the production keys, particularly in a sort of sensitive environment. So if you're not going to bake the secret into the image, you have to somehow get it into the container at runtime. And there are basically two approaches to do this. The first is you could pass it in as an environment variable. 12-factor app manifesto taught us to configure our code using environment variables, so this seems like a good thing. But there is a very strong argument that says it's very easy to lose control over your environment variables, in the sense that a lot of software, as soon as anything bad happens, it might log out the state of the environment. Your log then contains your secrets in plain text, and that is potentially a bad thing. So the other way of getting secrets into a running container is by mounting a file system. But Liz, you said a minute ago, don't write plain text secrets into files. So this needs to be a temporary file system on the host so that it's only held in memory, it's not actually written to disk. So that's the kind of principle that needs to be happening under the covers. Now let's have a look at what actually happens with some orchestrators and what support they have for secrets. So we'll start with Docker. And who's using Docker? Lots of people are using Docker. Is anybody using Docker Swarm? A smaller group of people, right. So Docker Swarm has really nice secret support built in, but unfortunately it is only built in for Swarm and not for standalone containers. It works really nicely out of the box. Now this is where I will probably find out, oh, my virtual machine hasn't aborted yet. That's a good start. Okay, so I have some secrets. Let's have a look. And I also have, hopefully, a running service. Okay, and when I created that service, I basically just passed in the secret that I wanted to have access to. I can find that container that's running as that service, and I should be able to exec into it. We'll run a shell. Okay, one of the things that the Docker secrets implementation is quite opinionated about is they don't support using environment variables. So your secrets are always passed in through the file system. And if we look in run secrets, and I think it's my secret we've got in here, that is the secret value that I passed in. So it's available to the code running in the container by simply reading that file in this well-known location. It's always run secrets. Okay, let's have a look at this from the host perspective. So I just want to sleep for a little while. And in this window, I'm on the host, on the same machine. And I can, look for that process. And I can find all sorts of interesting information about that process, in /proc under its process ID. And it includes the mounts to 602 mounts. And there are actually loads of file systems mounted, so we'll just grep for secrets. Actually, let me do that a bit higher up the screen. And you can see that it has indeed been mounted as a temporary file system, which is exactly what we wanted. Hooray! So that's good. Let's get out of the container. Now, the things that you can do with a secret in Docker, you can create them, you can inspect them, you can list them, and you can remove them, but you can't change them. So I don't have a way of just updating that secret value if I want to revoke or rotate the key. And I also can't remove, it was my secret, I think. yeah, I'm not allowed to remove that secret because I've got a service currently accessing it. So the only way of rotating a secret is going to involve either deleting stopping the service, deleting the secret, recreating it with the same name, and restarting the service. Or I could add a new service. I am allowed to, let's have a look at Docker service update help. So there's a couple of options up here for adding and removing secrets. So I could add a new secret to the service. When you update a service, it will restart the container, but that's okay. Your container code is going to be resilient to failures and restarts anyway. You can add a secret, it will have a new name, so your code would need to know to look in run secrets and more than one file name to be able to rotate the key. Okay, so that's pretty much what happens with Docker. They do have some access control in the Enterprise edition. Let's have a think about where they store secrets. They're stored encrypted in the raft log, and the raft log is what the swarm nodes, manager nodes, use to share states and share information between themselves. They are encrypted in the raft log, but, and this is the one thing that doesn't work completely out of the box with Docker Swarm secret support, by default, your swarm is unlocked, which means there is a key that you could use to decrypt the log written to file just sitting there on your host, which is not ideal because anybody who gets access to your machine can then easily decrypt your raft log and see all your secrets. You can solve this by locking your swarm. It's easy to do, but you just have to remember that you need to do it. And locking your swarm means you get given a new token that is never written to file, and it's up to you to store it in like a secrets store management, a password manager or something like that. Swarm also has really nice end-to-end encryption between all the nodes, so the sort of encryption between machines is taken care of for you. So lots of really nice stuff in that support, but a couple of things to be aware of. Kubernetes. Secrets in Kubernetes are like kind of all the resources, they're configured as YAML, and they can be namespaced, which already gives us a certain amount of isolation between different projects. Let's have a look at YAML file for a pod. No, that has access to a secret. So Kubernetes supports both methods for getting secrets into the container, both the environment variable and the file method. And this particular pod has both. So we've got a volume mounted that's going to appear at /secrets. Kubernetes lets you choose where you're going to mount your secrets from. And I've got a different secret being passed in as an environment variable. The secret definition, it's YAML, so it's verbose and kind of, 8 lines to say I want to pass in this secret, but there it is. So if I look at my running pods, oops, there's my secret pod, and I can exec into that. We'll run a bash shell. Okay, and we can see, I think it's my secret maybe, we can see the secret value in an environment. And we can also look at, I think is it secrets, your secret? Yeah, there's another secret, the one that we passed in as a file. In terms of rotation, if you change the value of the file secret, that will get updated live into the container. But if you change the value of a secret as an environment variable, you would need to restart the container to pick up the new value. Okay, so Michael talked quite a lot just after lunch about etcd and the things that are stored inside etcd. And secrets are no exception. They are also inside the etcd store, if you like. So let's take a look at that. So this is just happens to be the IP address of my my Minikube node here. This is the port for etcd. It's under the registry, it's secrets. I'm in the default namespace, and I want to look at the secret called your secret. And here we go. This looks, I can see the name secret, I can see your secret.txt, and I can see something that doesn't look at all like don't tell. Oops. Let's see if I can actually copy that out, even though it's split over over a line. This is really awkward. Okay. Now, as you may have guessed, that is not actually encrypted. That was just base 64 encoded, and encoding is not the same as encryption. So what's going on there? What's going on there is that by default, your etcd contents are not encrypted. It is possible to set up the encryption, and obviously if you're going to store your secrets in there, you would be well advised to do that. And you do that by passing in a config file, a YAML format config file, when you start the Cube API server. And that config looks a bit like this. You say, I want to encrypt the secrets resources, and you have some mechanisms that you're going to use to encrypt. And this mechanism uses a key to encrypt, and it says secret. So you've got a secret in this file. Right? So anybody who has access to this key will be able to decrypt everything that's in the etcd log, even though it's encrypted. And this is generally the problem with encryption, right? You know, you have a thing that's encrypted and you have a key. So how do you keep the key to that secret? You can't sort of encrypt that because you'd get another key, and you just, you know, eventually you've got a key that you've got to do something with. At the moment, the advice in Kubernetes is to basically restrict access to the encryption config file to make sure it's only accessible by the user that starts Cube API server. I guess maybe it would be possible to do something like remove the file after it had been used, something like that. Kubernetes has role-based access control that you can turn on so that you can say certain users can have access to certain secrets or certain namespaces. I won't go into all the detail of that, but one thing to be aware of, even if any user who has access to a pod will be able to exec into that pod and see the secrets, even if you didn't give them secrets access through the role-based access control. So again, just something to be aware of. I'm going to skip very quickly through the next couple. Anybody using DCOS or Mesos? Yeah, a couple of people, right. Enterprise DCOS, I believe, has secrets management built in, and there's sort of plugin support available for Meson. I made that up, Mesos. This ends up with your secrets being stored in Zookeeper, which I like to think of as a sort of prehistoric version of etcd. And there is some level of access control. They only support the environment variables injection method. And again, you would have to restart containers to update the values. Nomad. Anybody using Nomad? Yes, there's somebody at the back there using Nomad. Yeah. The amount of time I've spent using Nomad is probably about the same time as the length of this presentation, so I cannot claim to be in any way an expert. That said, they do integrate with, it's a HashiCorp product, they integrate with HashiCorp Vault, which is an extremely well-respected, I would say, storage solution for secrets. I'm led to believe that this is a very nice integration. And then finally, since Aqua does pay my bills, it seems like I should show you something that we do, I think, pretty neatly. It's kind of nice. I'm not going to go through all the details of how great our support is, but I want to show you the secrets support. I hope this is going to show up, be big enough. Okay, I have a secret in here called Aqua My Secret. And as an administrator, it's this sort of write-only access, so I can't see what the value is, but I'm just going to change it and save the changes. And I can see here that there is a container that has access to this secret. And I can see that it's a Redis container running on my Minikube node. So I'm going to go back to my Minikube node and, oops, I wanted to do it in this window. Kube-get pods. And I know it isn't the Redis secret one, so it must be this other Redis node. And I'm going to exec into there. Oops. Get a shell. And much like the CubeNettie support, we can see this in the environment, hopefully. Yeah, so that was what I just typed into the secret, hello container camp. And again, very similar to other support, we can see this inside a file. The same value is there. There isn't a new line, so it's slightly harder to read. Okay, but there are two kind of neat things that I would like to show you. The first is I'm going to do the same trick of sleeping for a bit and looking at the running process. Okay, so it's going to be 25015. So proc, did I say 25015? About right. And the environment variables are all stored in this directory, but they're null separated. So let me just convert the nulls to new lines. Oops. Okay. And in here somewhere, there's loads of environment variables, but you see here, what we actually passed in was not the value, it was a key to the value. So it's just making it slightly harder. If somebody was able to get access to this host, they don't immediately get to harvest the secret values by looking in the /proc directory. The other little neat thing I want to show, it's just, oops, is what happens if I change this value again. So I'm just going to change this. Okay, so I've changed the value. Incidentally, I do also have an audit log here of everything that's happened. I can see that I changed that secret. I changed it a couple of minutes ago. And now, if I do the same thing, look at the secret value, we can see it has indeed changed, both in the file system version and in the environment value version without me needing to restart the container, which is quite nice. And I believe, none of the orchestrator solutions support doing that. So that's quite cool. Of course, you should be able to restart your containers. They've got to be resilient anyway. So, maybe you don't need that, but it might be cool. So just to kind of sum up, the choice of how you're going to manage your secrets, it really depends on your orchestrator. You're not going to choose an orchestrator based on its secrets management alone. And depending on your organization and its needs, you could very well find that the orchestrator you use gives you an appropriate level of security for your secrets. Hopefully a couple of things there just to be aware of, that if you're going to use them, you should be turning on, like encryption and locking your swarm, things like that. Obviously, this has been like a super fast run through of some of the things that are available in the world of secrets management in containers. We do have a white paper available, which goes into a lot more detail and covers a couple more orchestrators as well. So I'm afraid you have to sort of register to actually download that white paper, but that's kind of, it's okay. And there's lots of really good detail in that white paper. So I'm going to be really thankful to the demo gods, because the VM that I used for the Docker demo crashed like 3 times in the previous break. So I'm pretty happy with getting through that demo without any more VM aborts. So
thanks very much.